Hey guys, I'm gonna walk you through some of this circuits activity that I have set up. Here you'll notice I have two screens set up, so it's gonna be a little bit confusing, but I feel like this is gonna be the easiest way for me to show you what's going on. It's not gonna be very long. A lot of this is exploratory for you folks to try. So we're gonna work with electrical circuits so we can work with some of those equations that you've been practicing, the V equals I times R, the P equals I times V, and get some real application to it. So in our directions, it says right away, click on this website. This is phetcolorado.com. So when you do that, you're going to get to a page that looks just like this. That's what my little picture shows here. Then I ask you to, once you get here on Google, you're just going to click on that link. And you'll see this black screen appear, hopefully. And then you have to pick either intro or lab. Now they're basically the same thing, so I say just click on the intro part, and then I'll just move this over so you can see everything that's going on. You have this workspace here. So as I go through, or as we go through in this activity, this first part is exploration. It says take 5 minutes to build a working circuit. So all you're going to do in this first time, and this is all strictly you, look at all these things you get to play with. You just really pull anything out of here, like a battery, like a wire. Maybe I want to have two batteries, and I want to connect them maybe to a coin, because coins are made out of metal. And whoops, then see these little dots here? That's where everything gets connected to. Oh, nothing's happening because I need to close my switch. Now, notice there was a fire that broke out because there's zero resistance, remember that electrical friction, in our circuit. So I definitely recommend, even though a circuit doesn't need a light bulb or a resistor, I definitely recommend that. Now you can play around and see like, hey, is my finger... Nope, nothing happens there because I or you have too much resistance. That's why you can touch a battery and nothing bad happens. But I ask you to play around with it, add different things, and just see if you can get electricity to flow. Then this button in the bottom corner, that's a reset button. So that resets everything. So after you explore everything, the next thing that we ask you to do is draw a picture. Now obviously this is online, so it's hard to draw a picture. If you want to print it out and then cell phone, take a picture of it and email it or submit it to me and Mr. Nabel, that'd be great. If not, you can just take a screenshot of what you build and then drag it into your document. Now, when we're going to start measuring things, I ask you to be sure to click on this button that says conventional current. Now, that means here in the United States, we use something that's called conventional current, which means the electricity gives it a direction. We say the current comes out of the positive side, that's the side with the button on the top of the battery, and into the negative side of the battery. So make sure that button is clicked. And now I'm just going to build a nice simple circuit. Now, one mistake a lot of people make is, again, these red little circles, that's where everything has to get connected. Now, if I connect things by mistake to the wrong circle, notice the light bulb doesn't light up because that's like when we built the wire, the bulb, battery, and wire activity when the light bulb wouldn't light up. We make a short circuit, and that's hot because you burned your fingers. So I'm going to just select that and press delete. So now that button is gone, or that wire is gone rather, and I can turn my light bulb. Just going to make it nice and square if I can. So I'm adding extra wires, which you don't need to do. And there we go. Now in my directions for you, it says now use the voltmeter and non-contact ammeter. A voltmeter is this thing right there. It says voltage. And notice it's got a black side and a red side. The red side we refer to as the hot side. That is always going to the positive side of things, or where the electricity is coming out of. The black side is the negative side, and that now will tell me the voltage of my battery. Now, if I want to test something else, like my light bulb, same thing. We can see the red arrows coming out of that side, which means I'm going to put the red arrows, or the red one there, the hot side, and the black one on the, oh man, did I make a mistake? It looks like I made a mistake. How do I know I made a mistake? If I look at the voltage now, it's -9. That just means I'm measuring in reverse. So to fix that, and I did that on purpose just so you can see, to fix that, all you do is switch the direction. Move that one over there, move that one to the other side, and now I have a positive value. So it doesn't matter what we're measuring. If I wanted to add, say, a resistor, resistors aren't as interesting because you can't really see anything happening, like the light bulb light up. So same thing, if I wanted to add a resistor, if I put that one there and that one there, oh, I got a negative again. That means I did it backwards. So put the black one on that side, put the red one on the other side, and now it is positive value, so that is correct. Notice it's kind of opposite of how my battery is set up, but that's okay. Then to put it back, I just have to drag it back into where it says voltmeter, and it goes back in. This thing is called a non-contact ammeter. And an ammeter measures the current in the circuit, or the amps. So I take it somewhere where I can see, and then all I do is I put this little target on the spot where I want to measure. Bang, right there. And this ammeter literally counts the charges. And charges per second, that is the current. How much electricity is flowing through. So I can put it anywhere I want, and it will measure the current right at that spot. So those are what we're going to play with. And then throughout this whole lab, I ask you to make one with 2 light bulbs, make this is, remember, a series circuit, because there's only one path for electricity. This is a simple circuit. A parallel circuit is something that we haven't talked about a whole lot yet. A parallel circuit is if I have more than one path. So here's one path. A parallel circuit would be like adding a second road, a second path. That goes like that. That goes like that. And now I have a whole second path. Electricity gets to go this way if it wants, or gets to go that way if it wants. Every time I'm done, I can just press the reset button. Now let's go back and look at the lab. There's a prediction part. What do you think will happen when I compare a series circuit, one path, to a parallel circuit, 2 paths? There is build a simple series circuit. That's the one path, and then some questions. And build a simple parallel circuit. That's the 2 paths with some questions. Now, Mr. Nabel and I will go over this the next time we talk via our Zoom video. So hopefully you've watched this, you've previewed this, and then we can take some questions and walk you through it again. Remember, if there are any questions, by all means, you can always email me and or Mr. Nabel. That's all I have for you, folks. I hope you all are doing some fun stuff. And if you watch this, I'm going to know if you watch this because I want you to ask me on Monday. I see you folks on Monday. Ask me on Monday about the squirrels. If you don't ask me about the squirrels, I know you didn't watch. All right, folks, that's it. Hope you all stay safe. Have a good weekend. Bye.